Hello everyone! So there's one thing I already noticed about my own existence here. Everything is blocky. Animals are blocky. Villagers are blocky. Monsters are ow! Ow! Ouch! 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 Go away! Go away! Even cakes are square here. Ugh. So, as you can figure out, today's episode has to do with pies! Okay, maybe not this pie. Pie! That's right. Today we're going to take a look at this magical symbol. Hold on to your circles, everybody, because today's episode is about pi. So pi is a really fascinating number that was discovered in relationship to circles. And as we can see, there are no circles to be found in my universe. All the way to the horizon, not a single circle. Oh. Well, hello. Okay, I cheated. I created a circle. But I had to create it with blocks because that's all I have here. And in order to see it as a circle, I had to go up. As you can see, I am a little ways up here. So we're going to look at this as our reference to kind of think about what pi means in the real world, and then try to figure out if we can make that equivalent into my current universe, which, as you can see, has no circles whatsoever. So pi is really, really old concept, actually. But in short, people saw, and scientists saw, circles all around them in the real world and made a discovery that really there's a relationship between the circumference of a circle, which is all the way around, and the diameter, which is the length between one end to the other. It's basically the double of the length between the center and any point on the circumference. And if you divide those two, so if you take the length of the entire circle outside of the circle and divide it by the diameter, you get pi, 3.14, and a whole bunch of other numbers. That is the relationship. And this is really useful because the real world has a whole bunch of circles. And we discovered that we can use that number to make other calculations a lot easier. But, as we've pointed out before, this universe doesn't really have a lot of circles, if any, at all. So, what would be the equivalent of pi here? Well, if we consider the fact that this is really the relationship between the outside, the length of the outside, to the length of the kind of the thing that cuts it, then maybe we can make that kind of equivalent to a block, a square, which is what I do have to work here. So, I made a little square for you. Right here. Hello, square. Ooh, there's a sheep in it. So if we think about this square as the equivalent of our circle, so this is my universe's equivalent, then the circumference is the entire red bit. It's the length of that. And the diameter is twice the length of that blue line. And if we consider, just for ease of calculation, that each side, let's say, is 1 unit long, then the circumference is 1, 2, 3, 4. And the length of the diameter is basically the length of one of the sides, which is 1. So 4 divided by 1 would be 4 without any numbers after it. Well, 0.0. So I guess that's a number. Which would mean that is pi 4 in my universe? Well, we could test that idea out, because that might actually be true. It could be 4 here, which would explain why we have no circles. So the only way to test this is to see if it works out. And I actually created a couple of equations over there for us to test, but I'm going to need to get down in order to go there. So, Geronimo! Whew. So I made some equations for us. Don't worry, I do not expect you to solve any math. But, like any piece of science, math is helpful. And it is also the source and the usefulness of pi. Well, we know that in the real world, the way to figure out the area of a circle is pi r squared. Well, let's test it out. If pi is 4, and I have a square... Let's see, where are my squares? Here are my squares. Whoop. So let's build out the square here. 1, 2, 1, 2. So I have a square that is 2 over 2. What would be its area? Well, it's going to be r. Don't forget, is not the diameter. It's half of the diameter because it's from the center onwards. That's r. That's the radius. So in this case, we have 2 over 2, which means that r is 1. So 1 squared is still 1. And pi is 4. So this area is going to be 4 times 1, which is 4, which is what we would expect the area of a 2 by 2 square. Ooh. All right. This is promising. Let's try another one. Just for ease of calculation here, I'm going to create one that is 4 by 4. Get down here. All right. So this one is 1, 2, 3, 4 by 1, 2, 3, 4. Right? And we know that this area here should be 16. But is it? Well, if we look at our equations here, we said pi is 4. Well, what is r? R is half of 4, which is 2. What is 2 squared? Another 4. So we would have here 4 times 4, which is 16. So it works out. Hey! Well, maybe pi is 4. Maybe it's actually working out here. And that's pretty cool. Well, let's try another thing. Let's see here. If we pass this little... Oh, what do we have here? I made a sphere. Well, I tried to make a sphere. This is kind of... You're going to have to use your imagination here. This is supposed to be a sphere. Because, again, there are no circles here. So it's kind of like the closest I could get to a sphere, okay? Bear with me here. Here we go. So I made a sphere because we're going to now look at volume, which is this equation. I know. Don't panic. We're not going to have to calculate anything. Or rather, you don't have to. I already did. So let's just use it to test if everything's okay. We said pi is 4. All right, well, what would happen if we had a box now that is, let's start with, let's say, 2. So it's 2 here over 2. So now I need to make it 2 deep. 2 over 2. All right. So now I have this cube that's 2 over 2. Well, we expect this volume from what we know to usually calculate, like the volume of a cube, to be 2, right, times 2, which is 4, times 2. So now if we look at this equation here, let's see if that works out. Well, we have 4 over 3 times pi times r cubed. Well, remember, our r is half of this length. So if we have 2 as the length here, r is 1. R cubed is 1 cube. It's still 1. I know. It's as if I really planned on, trying this first. So we have 4 over 3 times 4, because that's our pi here, which means 16 over 3 times 1, which is definitely not a volume here. Okay, that doesn't work out. What is happening? But it worked out so well. Could pi not be 4, or could this not be right? But it was so promising. So I'm back here in my circle tower to try and figure out what happened. So let's think about this for a minute. Pi, we said, was the relationship between the circumference of the circle to the diameter. But there is one thing that we neglected to think about when we thought about the comparison later to a block or a square. One of the things that are happening here with the circle is that the circle is this magical, really, shape. It's very unique, where every point on the circumference has the exact same distance from the center. This is one of those things that scientists in the past, when they discovered pi, were thinking about. This is a really unique property that is only unique to the circle. That is not true of the square. You see, we have here this length from, the left part to the right part would be 1 if we said that one of the sides of the square is 1. But the length would be very different if we decided to take the diagonal. Now we could say, well, What if the relationship between the circumference and the diagonal would be our pi? Sure, but if we do that, then the area calculation that we had over there won't work either. And the idea here is that pi is not something that is a property of a universe, of any universe. It's not like this magical physical constant that has to exist. Pi is a representation of a recurring phenomenon, a recurring pattern that scientists discovered, that by giving it a name and giving it a value, they saw that because it is recurring, it can be helpful in calculating a lot of other things. But since I don't have circles here, then the idea of pi, this idea that the relationship between the circumference of a circle and its diameter is important, might actually not quite be true for this universe. I don't know if I have pi as a thing here. I might have something different. Maybe when we start looking at this universe and looking at things, because blocks are the ones that are the basic unit here, then maybe there is some sort of other pattern that I will discover that has to do with, the structure of a block or the structure of a square based on some other property. That won't really be pi, but it will be something different, something that will help me make sense of this universe. And that's kind of a point here, I think. This is a really, really cool aspect of science. You can't really bring other concepts from other universes into this universe and expect them to just work. Because what went into discovering pi and what went into discovering that 4/3 calculation that we saw was people first started from the very basics and then made observations that were true for the universe they were in, and then simplified and unified them and made them into recurring symbols that anyone else can now use in order to simplify the world around you. Which basically means that I need to get back to basics when I check a lot of those things in this world. I don't know how much I can rely on simplified versions of calculations, because those things rely and depend on assumptions that were made on your world, not on mine. My circles are still blocky. And maybe if I go and start looking deeper into squares, I'll find another magical property that recurs around the world, and it won't really be pi, but I'll be able to name it whatever I want because, I'm the only one in this universe. So, maybe I'll call it Pooey. That's going to be cool. A new constant named after, half of me. Well, I guess that's it for this episode. This was fun. Except I'm kind of stuck here and the only way down is to fall down. So, wish me luck, everybody. Wait. Before you go, check this out. I found something. Look. It's a giant shoe. It looks like I wasn't the only thing being pulled into this universe. And look over there. What is that? Is that a coffee cup? What is happening?